Hey, welcome everybody. It's Mr. Klinkerman here. We're moving on to Chapter 3 finally. And in Chapter 3, the first thing we're going to be doing is we're going to be working with identifying pairs of lines and angles. Alright? Identifying pairs of lines and angles. Now, I've got some learning goals for you for this lesson, as usual. And the learning goals for this lesson are these. First of all, you're going to learn to identify relationships in space. Now, that kind of sounds like we're talking about outer space, something like that. Nothing of the kind. But when I'm talking about identifying relationships in space, we're talking about where we're going to have to start thinking three-dimensionally in a space instead of two-dimensionally, which would be inside of a plane. All right. Then the second learning goal, which will be the next video, is that you're going to identify angle pairs that are formed by three lines that intersect one another. Often we'll say two lines in a transversal. Okay, so identifying relationships in space and identifying angle pairs formed by three intersecting lines. A ton of vocabulary and concepts for you to understand here. None of it difficult. It's just going to take some memorization on your part. Alright, well let's go ahead and start with identifying relationships in space. And the way I'd like to do that actually is by talking about relationships in a plane to begin, because, well, I've got to compare two-dimensional to three-dimensional if you're going to understand what we're doing with relationships in space. Alright, maybe I should add one more word here, because there's a certain type of plane relationship and space relationship that I'm looking at, and that is for this. We're really going to be talking about linear relationships in a plane. Alright, so what are the different relationships that two lines can have is what we care about. And it turns out that when you're talking about in a plane, there's only two relationships that a pair of lines can have. And this would be one of them. In a plane, two lines could intersect one another, like so. Alright, so you can have intersecting lines. And of course, if two lines don't intersect, you already know the other possibility. And the other possibility is that the two lines are parallel to one another, such as these lines right here. Okay, now while we're talking about parallel, I want to stop and teach you a little bit of notation. Let me label these two lines as line A and B. There's a symbol like what you've seen for perpendicular lines that you can use to say that two lines are parallel to one another. And that symbol is simply a couple of parallel lines. It looks like you're drawing an 11, but you make it a little bit bigger than 11. This right here it says that A is parallel to B. Alright, so two-dimensionally, lines either have to intersect or they have to be parallel. But what about when we start thinking about three-dimensionally? Turns out there's one other case to consider besides intersecting or parallel. And I want to show this to you in a picture. You recognize this place? I hope so. And what I want to do is I want to examine some various lines that you see in our classroom. And you need to think three-dimensionally for this to make sense. Now, you can still have lines that intersect one another. And I'm going to draw a couple of them right now. Alright, now we're going to focus on that chair that's sitting on top of those two desks. What in the world's a chair doing sitting on top of two desks? Anyway, it's there. And here's where we're going to start looking at some lines. Let's consider the front edge of that chair to be a line. Okay, well, that line intersects about four other lines that you can see in this picture. One of those lines being this leg on our front left side. Okay, now a quick note here. If we're going to have lines that intersect one another, it has to be possible for them to be contained within the same plane. And you could imagine that if I drew a plane right here that contained that front edge of the chair, so to speak, that plane would contain both of those lines, and so, hey, those lines can intersect. Lines must be coplanar to intersect. Alright. Well, it's also possible for two lines to be parallel to one another when we're thinking about three dimensions. And I'm sure you can think of some lines that are parallel. I'm going to draw a couple right now. Let's say that the back edge of the seat right there is a line. And then we can use the front edge again. Those two lines are parallel to one another. But I need to make it clear that it's not like they're parallel just because they that they don't intersect one another, because it's possible for lines to not intersect and also not be parallel. These lines are parallel because they're coplanar and they don't intersect one another. It's possible, as I'm going to do right now, to draw one plane that contains each of those lines. In fact, I'm not even going to draw it because it's already there. Isn't the seat right there a plane? Okay, so these two lines are coplanar and they don't intersect. That makes them parallel to one another. Alright, well, what's the third option? What happens if two lines are not intersecting lines and they're also not parallel to one another? Can you imagine any lines in this picture, in particular that are part of that chair, that neither intersect nor are parallel? Well, I'm going to give you a couple. Let's say we look at the back edge of that seat again. There's a line right there. Okay, and then let's say I compare that with that front left leg. I'm going to make this a different color. In your mind, I think you can imagine how those would not intersect one another. There's no way they would intersect one another. Now here's the other thing. There's also no way for you to draw a single plane that would contain both of those lines. Because any plane that's going to contain this leg, this front leg, is going to have to be going straight up and down. So you're thinking vertically from the floor to the ceiling. And any plane that's going to contain this back edge right there, well, it kind of needs to stretch from left to right, not from up to down. There are some up to down ones, but you get the idea. You can't possibly draw a single plane that contains both of those lines. What do they call that whenever two lines are not parallel, but they also don't intersect one another because they're not coplanar? Well, it turns out they call those skew lines. And I imagine you can see several more examples of skew lines within the classroom. One more example of skew lines that I'm going to show you here. Let's say we look at one of the lines formed along the floor right there. And what if I compared that then to one of the desk edges? Let's say the edge of this desk right there. Alright, well, those lines aren't going to intersect because the one that comes from the desk is above the one on the floor, obviously. But those lines also are not in the same plane. So they're not parallel to one another, they're skew. And I'll write that word out. Skew is spelled S-K-E-W. Okay, so what we need to do in this video is we need you to be able to identify when two lines are parallel, when they're not, when they intersect, and when they're skew. All right, we're going to throw in one other thing. You also ought to be able to recognize when when planes are parallel to one another. But I think you've got a pretty good idea of what parallel planes are. For instance, the seat right here, the plane that contains that would be parallel to the plane on that desk right underneath it, right? They're both horizontal, one's directly above the other. They're not going to intersect one another ever. Whereas, if you look at, say, the plane that contains the left side of the chair, all right, that plane would intersect maybe the plane that contains the top edge of these two desks right behind the chair. All right, because the plane extends forever, those would have to intersect one another at some point. All right, so relationships in space. We just said that there were three when we're talking about linear relationships specifically. All right, so one of those relationships is that you can have lines that are intersecting one another. And of course, the qualities that make lines intersect, well, they intersect one another And intersecting lines are always coplanar. And I've got this nice little pyramid over here to illustrate some of these types of lines for you. And you can imagine, for instance, how line JP intersects line JD. And of course, our intersection is a point, and that point is J. All right, and then after intersecting lines, the next relationship we talked about is that two lines can be parallel. And there are two requirements for lines to be parallel to one another. One of those requirements is, of course, that they do not intersect. And the other of those requirements is that parallel lines must be coplanar with one another, meaning that every point that appears in either line has to be in the same plane as points that are in the other line. An example of coplanar points in this picture, not coplanar points, but parallel lines in this picture, there's only two of them, it turns out. Line VP is parallel to line DT, right? They're both in that bottom plane and they don't intersect one another. And there you can see the notation that I would expect you to use if you were trying to say that two lines were parallel to one another. The other pair of parallel lines that are in this picture would be these two lines PD and VT. Alright, so that's parallel lines. The third relationship we said is that lines that are in space, and that just means in 3 dimensions, can be skew to one another. So let's examine that. Alright, and just like with parallel lines, there are two conditions that must be met in order for lines to be skew with one another. And the first of those is that skew lines do not intersect. But the second of those conditions is that the two lines are skewed, they are not coplanar. Alright, so within this diagram, where do you see some lines that are skewed? Well, let's use that front edge JP again. Do you see a line that's not in the same plane but also doesn't intersect that line JP? Well, here's one. How about line VT? One would cross right over the other. So they don't intersect, but they're not in the same plane, so they're skewed. Now, there's not any special notation for saying that lines are skewed to one another. You just say that the first line is skewed to the second line, as I did right there on your screen. Alright, another pair of skew lines. Well, how about that bottom left edge of the pyramid, line PV, and then this front right edge going kind of diagonally up, line JD. Those are also skewed to one another. They won't actually touch because they're not in the same plane. Alright, hope you understand these various definitions. Want to look at one more slide here and one more figure. And what I'd like is for you to use this diagram to find an example of each of the following. Alright, I want you to find some parallel lines for me. Then, how about some skew lines? Now, I'm not asking you to find every pair of lines that are parallel or every pair of lines that are skewed, but I would like you to find some. And then I'd also like you to find a pair of parallel planes. Alright, we don't need to focus on intersecting lines, that's a little bit too easy. But see if you can pause the video, find some examples of each. I'll probably find different examples than you will. Nevertheless, let's see if you know what you're doing. Alright, how about saying that line AD is parallel with line BC? Alright, that's easy enough. Those are both here in this front plane for that rectangular prism. So they are coplanar. You can see the plane that these are both located in. and they don't intersect one another. All right? And then how about this for another pair of parallel lines? Line AP is parallel to line CR. Okay, now this might be a little bit less obvious. You see line AP as this top left edge, and line CR is the bottom right edge, and you might say, hey, those aren't coplanar. Where's the plane that contains them? Well, the answer to that is that lines are coplanar if it's possible to draw a plane that contains them. And I'm going to draw a plane really quickly that contains both of those. How about this plane ACRP right there? Okay? So, those lines are parallel to one another. How about some skew lines now? One good example of skew lines would be that line AB and CR are skew. Alright, you can see how these two lines, they're not going to intersect one another. One's going just forwards and back, the other one is just going straight up and down. But certainly they're not going to intersect one another either. How about another pair of skew lines? And let's say we use maybe line AP and line CD. Alright, again, another pair of lines that clearly don't intersect one another, but they're also not coplanar. So, they're skew, not parallel. Alright, and then finally, some parallel planes. Now remember, you have to use 3 non-collinear points to name a plane. Nobody has trouble understanding that the top of that prism is parallel to the bottom, or the left is parallel to the right, but they do have trouble naming them so far. If I wanted to say that the top plane is parallel to the bottom plane, well, an easy way to do that then is to say that plane ADS. Alright, I just put any of these 3 points that are in that top plane in order to name that plane. The top plane is the only one that contains AD and S. So plane ADS, and then I could say that's parallel to plane BQR if I wanted. Alright, and then of course, similarly, I could say that the left side of the prism is parallel to the right side of the prism, and I could call the left side plane ABQ. That would work, right? And say that that's parallel to plane DSR, and make sure you write the word plane, and then write the 3 points that you're using to name the plane afterwards. There you go. There are relationships in space. See you in class.